Good morning. My name is Yunong Xiao. I am a director of engineering at Google Cloud, responsible for product engineering for our serverless portfolio. We'll get into that in a little bit, but it's really good to be here. Thank you for the introduction. And let's get into it. So we'll first talk a little bit about Google Cloud, what that is. I'm sure you've all heard of this before, but we'll go into some of the details. And so most of you sort of equate Google with sort of the consumer suite of products, right? Search, apps, et cetera. But Google Cloud is actually, our sort of premier infrastructure product. And one of the things that we do really well at Google Cloud, at Google generally, is we've been the leaders of AI for the last decade plus, right? So you may have heard of things like Google DeepMind, et cetera. And what we've really done at Cloud is really position it as an AI first product. So across our portfolio of infrastructure and platform and SaaS products, there's that really tight native integration with our industry-leading AI products. So you think of things like GKE, which is our container-based infrastructure product, things like Vertex, AlloyDB. Across all of our entire portfolio of Google Cloud products, there's great integration with our pole position leading AI infrastructure. Secondly, I think for Google Cloud, what we do really well is really around the developer experience. So for most of our customers, compute and infrastructure is a means to an end. It's to enable your business, right? And so how do you go to market more quickly? How do you become more efficient? Well, a lot of that comes down to how do you enable your developers to be more efficient? How do you get going from zero to production very quickly? And so that developer experience is definitely class leading and the strongest within the industry. So if your developers are looking at different cloud options and you look at Google Cloud, from our console to our development tools to the way that we structure our APIs, et cetera, all of that makes it very, very easy for you to get started, right? It makes it very easy for you to continue past the day one experience. And then lastly, I think there's a couple of things here. One, which is really our strong compliance and security posture, right? And so Google Cloud's available everywhere in the world. We are compliant across many different regulatory structures. And we have class leading security within our cloud. So it's definitely something that you can trust and go to market with. And then lastly, I think building on top of our strong foundations, our planet scale infrastructure for existing products like search, like YouTube, and like Gmail, right? And so the old adage of if it works for search, Google search, if it works for YouTube, if it works for Gmail, it'll work for you. So those are the advantages of Google Cloud, right? So just to summarize and recap, really strong native integration with our class-leading AI infrastructure, great developer experience, but also security and compliance. And then lastly, that really strong foundations on top of the planet scale infrastructure that we have. And so I want to actually double click a little bit about helping developers build applications faster. And so I think this is again an area where sometimes that folks don't really think about as much, but you should, which is really around how do I go to market quickly, how do I become more efficient, how do I leverage the existing folks that I have in engineers and the product managers that I have, and have them work more on your business logic, on your product, versus having to focus on infrastructure. And again, this is where really Google Cloud shines, right? So you can get started very quickly. Developers can write code and fast and securely, and developers can ship fast and frequently with Google's scalable and fully managed container environments, right? And lastly, as we alluded earlier on, we just had Google Cloud Next, and you've probably all heard of Gemini and Gemini Code Assist. That is now widely integrated across all of Google Cloud. So whether you're on the console, whether you're in a product, in a specific product, using things like Gemini Assist can really help you, one, go to market more quickly, but help you debug solutions as well, right? And so as sort of native integration, both in terms of your ability to integrate with large language models and build Gen AI applications on the workload side, but also on the developer experience side of making it very easy, having a code assistant that's going to help you develop, debug, and operate your cloud, right? Really makes it easy and for you all to go to market much more quickly.
Easily is generating code easily with AI is kind of a given. I think maybe where it gets more difficult is it going to work? Does it work within my system? How can I test? Regression test, like all of that sort of thing. So what are you focusing on in terms of it being easy? Because it looks easy already. seems easy already.
Right. So there's a few things there, right? One, the cloud's actually really difficult to use. If you've ever worked with the cloud, look at some of our competitors as well. It's thousands of APIs with documentation spread across thousands or tens of thousands of pages, and to go even from zero to an application is quite difficult. You need a bunch of just prior art and knowledge and expertise in that area to be able to build a highly available, scalable, secure application. And so on the front side of that software development lifecycle, which is, hey, I want to go develop an application that's secure, that scales, having things like Gemini Assist, having a really great developer experience in the console, right? Having things like native Terraform integration across all of our products. Things like that makes it easy for you to start with the right patterns and the right infrastructure, the architecture to build an application. And then on the back end of that, right, I've got an application up and running. I want to operate it easily. I want to monitor. I want to debug. The sort of Gemini Assist part of it, where as it integrates with things like cloud monitoring, right, cloud operations, with all of our products there, makes it so that when you do have an issue on the back end, it's much easier for you to debug the application. Whereas if you think about traditionally in the past, customers are telling you, hey, your website is down, your application isn't working. You have to spend minutes, hours, sometimes days to debug that. You maybe need the expertise there, right? Having things like Gen AI and assistance that powers that can pinpoint without you having extreme subject matter knowledge, right? Really helps one shorten the downtime that you're there, but also helps you to go much faster in terms of debugging applications.
So does that imply with Cloud Run that, and what you're presenting to us today, that you're, I wouldn't say obfuscating, but you're providing a simplification interaction layer for the developers that kind of takes away some of the gated knowledge that you have to make choices between your different options?
Absolutely.
You're providing that as a...
Yeah, exactly. So I want to put a pin. I'll come back to that because we're going to talk a lot more about Cloud Run in a second. But that's exactly the value proposition of Cloud Run, which is lets you use the cloud without having to deal with the complexities underneath it.
So you were mentioning deploying and developing and deploying very fast. So I would like to ask, how do you ensure that the apps are secure? So how can developer make sure that these apps that they develop fast are secure?
Yeah, I mean, I think there's so the question is, how do we ensure that the applications are secure? And I think there's a couple of points, right? One, which is the platform that you build on top of. So Google Cloud is an extremely secure platform. We have to be, we have a very strong set of security teams and security principles in which we build our products. Things like having 2 layers of virtualization for the application, so that even if you escape the first sandbox, you're still within a sandbox. Build upon, again, the decades-long experience Google has there. So within the infrastructure itself and the services and the products that we offer a very secure environment. We're also compliant across many of the security regulations in the places that we operate. And I think lastly, from an application perspective, we'll get into this a little bit more as we talk about Cloud Run. Cloud Run itself offers you a really great developer experience, but it offers you a lot of these out-of-the-box solutions where they are secure by default, right? And so, some of my colleagues, Darren and Sridhar, as they talk to you more about the demos, work through some of the digital features, and walk into that as well. But largely, you can think about the higher level of the abstraction that you have, the more secure your application is going to be, right? Because there's just less surface area, right, for you to do, for you to have running security issues. So, cool. Let me continue. I want to sort of talk a little bit more about our container platform. So, as you all know, containers is really the lingua franca now of cloud, right? It's what everyone uses, and you may all know this already, but Kubernetes was an open source project from Google. And Kubernetes definitely has become, that 800-pound gorilla in the room in terms of container orchestration. And so Google has centralized the development operations on a consistent container-based platform. On average, we launch something like 4 billion new containers per week. And not only are third-party customers on Google Cloud using containers, but almost all of our Alphabet native apps are as well. So again, we'll get back to that. If it works for Gmail, if it works for search, it'll probably work for you and me, right? And then I want to talk a little bit about our Google Cloud Container runtimes. Again, I talked about these couple of things. So Cloud Run is our fully managed and highly scalable application development platform, right? It's simple, it's automated, and it's focused on developer products. So the simplicity, ergonomics, velocity, right? So if you have a new workload, if you have a workload you want to bring to Google Cloud, within Google Cloud, the way that we position the strategies, you should definitely look at Cloud Run first. Pick the simplest, easiest, most secure platform to start with, and it has a ton of flexibility there as well. And then GKE is our managed Kubernetes offering, right? It's easy for customers to build their own platforms. If you want more flexibility there, if you're already familiar with Kubernetes, again, that's a platform that you can use as well. And there is flexibility to easily move between these two platforms. So you think of them, while they're two SKUs and they're two different products, they're essentially the same platform. So if you have a workload on Cloud Run, you can move it on the GKE and vice versa. Go ahead.
All right, so I get a question on this, because this is something that comes up quite often. A lot of organizations want to move to a fully managed solution because it's a faster time to value, right?
Yeah.
Less friction, easier to deploy, et cetera. What do you lose by going to Cloud Run over GKE for functionality?
Yeah, I think it's there's always this sort of balance and trade-offs around simplicity, ease of use, and flexibility, right? And so the sort of analogy I would give is, Cloud Run, it's serverless, it's pay as you go, right? We maintain and manage all the existing infrastructure for you at planned scale. It scales up really well. But if you have a very specific way you like to operate your infrastructure, right? Let's say you're very opinionated about some of the specifics about the operating system or some of the specifics about the way that the infrastructure should scale, right? And those are sort of very specific demands, and you're going to lose the flexibility. So it's almost like when you take an Uber, you want to go somewhere, you're not really opinionated about the type of car you get or the route, but you'll get there safely and securely. Whereas if you are really opinionated about how you want to get there and the exact vehicle you want to take, then you're going to go and sort of pony up and sort of build your own infrastructure or use aids and something like that, where now you get a lot more flexibility, but you also have the trade-offs of having to manage that, having to have the expertise there to be able to manage the complexity there.
No,
Yeah.
that makes sense. So, and then your last green bullet at the bottom here.
Yeah.
Can you manage across each one?
Yes.
Holistically?
Yes. And so the way that, and we can get into that a little bit more, and I think we will at the demo, but essentially underneath the hood in terms of the configuration and all that, within Cloud Run and GKE, it's the same. So you can take a Cloud Run app, port it over to GKE and vice versa, and they're compatible in that way.
So before you go on,
Yeah.
you've used the same words about managing, fully managed, most managed.
Yeah.
Which is which on these two? I'm just confused as to what's going on here.
Is it like the same Uber driver is drunk or not, or?
So Cloud Run is a fully managed platform. You can provide it a container, and it abstracts away everything else underneath the hood. So you should think of it as you don't have to think about Kubernetes, you don't have to think about orchestration, right? You don't have to think about networking or any of those abstractions. You simply give it a container, which is your workload, and it'll scale up for you, right? In multiple regions. You don't have to worry about the auto-scaling policies. You don't have to worry about any of that existing infrastructure underneath the hood, right? And that's our managed container service. You just give it a container. GKE is our managed Kubernetes service. So what that means is its layer of abstraction is Kubernetes, right? So you can't just give it a container. You have to give it Helm charts. You have to give it config, right? You have to be able to manage the Kubernetes, and that is the abstraction, right? And so that's the big delta.
So, we're seeing in the marketplace sort of, the rise of platform engineering, right? As almost like a counter to the whole shift left, throw everything on the developer's plate. And it seems to me when I look at Cloud Run versus GKE, GKE is for those platform engineers who want to work with the Helm and Kubernetes and put in the guardrails and make that. Where Cloud Run is almost really down and dirty for the developer, just throw your container on top of it. Now, a lot of people are saying that that's maybe not a great, puts too much on the developer not to have this whole kind of platform engineers, SREs, kind of helping that. How do you see the future of these playing out?
I mean, I see it evolving, and this is what the doctor, because I want to actually talk about Cloud Run, and sort of I think that'll answer some of these questions. If you look at most products, right, when they first come out, right, it's like very complicated. The CapEx is high, the OpEx is high. The amount of expertise that you need to operate that product is high. And as it evolves, it naturally democratizes and it becomes available for everyone without that skill and knowledge that you need, right? And so that's where Cloud Run is going. That's where we think cloud computing is going, which is serverless. You don't need a platform team, right? And that Cloud Run is the platform team. Google is now your platform team. And so instead of having to reconstruct and hire platform engineers, and we see this with a lot of our customers actually. In fact, they've been able to pivot their platform teams away from doing platform work and work on their critical business logic and building their business. And so we see cloud evolving in that same way, where we provide the abstractions they're moving up stack, and so that you can move up stack without having to worry about that infrastructure and the management. And that, in essence, is the beauty of Cloud Run. And so what is Cloud Run? There's a bunch of really great questions. It allows you to run containers fast and securely in a fully managed environment. And I think that's the key part. It's fully managed. Right? You just provide a container. And it's Google Cloud Serverless Runtime. In fact, it's a lot more than just containers. You can give it source code. You can give it functions. It'll run those as well. But containers is that sort of common level of abstraction that everyone uses within the industry. And so it's really three things. One, it's the developer experience. So as we talked about earlier, simple, it's automated. We're the highest satisfied. We're the service that has the highest customer satisfaction within Google Cloud and the developer productivity. And you see all of this in action in a little bit as we went through some demos, as we talk about the roadmap. And then the runtime, right? It's capable. It runs on any container. And this runtime, just so you all know, is the runtime that powers all of Alphabet's native apps, right? So as we talk about that planet scale architecture, we're through Cloud Run really exposing that to all of our customers. It's on demand. So you only pay for what you use, right? And if you today have 100 RPS and tomorrow you suddenly go viral, you have 1 million RPS, it scales up for you, right? Without you having to do anything. And there's no infrastructure to manage. You simply give it a container, and you've seen in the demo in a little bit, you simply give it a container. There's no platform team because Google's your platform team. And I dare say Google probably does platform engineering better than most, right? Better than what we be able to hire outside of that. So, and then pricing. You'll probably all know this as well. A lot of machines sit around idling overnight, right? And so with serverless, one of its key value propositions is pay as you go. So you pay only when your code is running. There's a monthly fee tier. There are obviously community use discounts, right? But there's no flat fee. If you're not using it, you don't pay for it. And this has a ton of advantages in terms of architecture, right? So you can imagine I can provision my infrastructure, my Cloud Run instances everywhere in the world, in all the data centers. But if I'm not using it, it's free, right? But when I do need to use it, it spins up on the planet scale architecture of Google for you.
How is your how is your satisfaction and usability scores measured? How's that?
It's through surveys. It's through and it's through all the metrics that we gather. There's a standardized way that we do that at Google Cloud, right? And so and I'll defer to Darren, who will be up in a little bit. He can talk a little bit more about that during his section as well in terms of CSAT.
When you deploy a container in Cloud Run, I was just looking at it. So I just deployed a Go web app, and then I went into the YAML configuration. It's using Knative in the back end, right? So Knative is a method of running serverless workloads on Kubernetes. So is Cloud Run sitting on top of Kubernetes, or is Cloud Run utilizing the same APIs as Kubernetes, or a mixture of both?
That's a great question. So Cloud Run is using the same APIs as you said, as Knative. Yeah. That's our compatibility native between Kubernetes and Cloud Run.
Yeah.
However, Cloud Run sits on top of Google's planet scale. You can think of it as an infrastructure orchestration system.
Okay.
Right. So while Kubernetes may scale to 10,000 nodes, this thing internally we call it Borg. Some of you may have heard of that. Scales to millions of nodes.
Yeah.
Right. And so it is a much more mature system. Right. Its reliability, the infrastructure is much more mature. Right. And that's what allows us to be able to scale up your workloads reliably, securely. Right.
So Cloud Run sits on top of Borg?
Yes.
Interesting.
Yeah.
Okay. So then that's the difference, I would assume, between Autopilot and Cloud Run.
Yes.
Okay.
Yes. Good question. So some use cases for Cloud Run. These are just a few, but obviously it's a general purpose compute platform. The first one is public website and APIs, right? So things like server-side rendering. You may have APIs that you want, streaming. Lastly, Gen AI serving and orchestration, right? And so Cloud Run is the best place for you to serve your Vertex endpoints, your LLM applications, right? You may have a model that you have info that you want to serve. You still need the API for it. We definitely think, our guidance on Gemini GCP is to use Cloud Run for that, right? Again, take advantage of the scale to zero infrastructure. Private services like internal websites or APIs, HTTP or gRPC, web microservices. Also things like data processing, right? ETL jobs, batch, etc. So things to process messages, to do extract, translate, and load, right? To process your data platform, etc. Cloud Run is really great at that as well. We have a specific workload type called jobs, and that lets you run tasks to completion securely, safely, again, without any of that orchestration that's involved.
And which out of those three, do you have one that really stands out as the use case that gets deployed or utilized most often?
I mean, they're kind of, we like to say they're all of our children, so we love them all the same. And so it's really hard to pick. But what I would say is really, it's you think of like online workloads and offline workloads, right? So the services side of things, websites, APIs, we see a lot of traction there with a ton of our customers, but also with the offline cases, like where we have jobs and ETLs. In those types of workloads, serverless is a really good value proposition because you typically only run them periodically, right? Imagine a database dump or a weekly or nightly job that you have. You don't want to keep the infrastructure around for only when you for the entire week or entire month. So serverless and that value proposition works really well. And you can see that across our selection of Cloud Run customers across multiple sectors, right? Retail, tech, financial services, media, entertainment, manufacturing, et cetera. So you can see that a lot of not just hyperscalers and sort of digital natives, but a lot of the Fortune sort of 100, right? Sort of the companies are all transitioning to Cloud Run. And one of the key reasons, again, is that it makes it easy for them to go to market more quickly, right? And they can become more efficient. You don't have to have these large platform teams that you have to hire for. You have to build your own internal platform. You can leave all of that to us.
Would it be fair to say that Cloud Run services like don't necessarily fall under the standard serverless category? So like serverless, it's all triggers based on events that occur, but Cloud Run and jobs are doing that, Cloud Run jobs, but Cloud Run services aren't doing that. It's just like any other orchestration platform.
Exactly. And so I think this is a really great question, actually. Thank you for asking it. When serverless first appeared, 10 years ago, or, it was really around kind of these event-driven architectures, right? I have a queue somewhere. I only have serial processing. I may use a function, right? But I think what's interesting is that's not the way that actually solves a lot of the large problems in the industry. Like we love the serverless value proposition, scale to zero, right? No platform operations to manage. But in terms of actually sort of the methodology in which you process your compute, we still want to have things like multiple requests, right? Multi-processing, right? Service-based architecture instead of just event-driven. And so that's what Cloud Run is really about, is that we are subscribing to the serverless methodology in terms of like, hey, scale to zero, scale to nothing. But in terms of actually executing the compute, it's just like a traditional infrastructure as a service, general purpose compute platform.
Right. Okay. Makes sense.
So that's the key distinction. And again, it's available in all Google Cloud locations. And so wherever we are in the world, Cloud Run is, and you can be as well. Great. And I'm now going to turn it over to my colleague, Darren, who needs no introduction. Go through a demo.
Hi. This great Google Cloud and Cloud Run introduction. I'm convinced that the best way to get Cloud Run is just to try it, and in your case, see it. So I'm going to switch to a demo. And this demo, I'm going to be using the Google Cloud Console, which I find very visual to do demos. But everything I'm doing here, I could do it using the command line. I could do it using YAML files. I could do it using Terraform. All of those clients are fully supported by Cloud Run, and you get to pick the one that you want for your team. I think UIs are great for discovery. So let's discover Cloud Run. We see this is the empty state. I have no resource. I just have opened Cloud Run for the first time. And we've discussed that there are two main resources in Cloud Run, the service and the job. I'm going to be creating a service for this demo. And here we see two options. I can deploy a built container image, or I can actually deploy source code. In that case, I can even connect to a GitHub repo so that it continuously deploys my code as I push new changes to it. For this demo, I've already built a container image. I'm going to select it in a container registry. Google Cloud's container registry is called Artifact Registry. I'm going to be picking the container I've built already. If we have some time, I can tell you how I've built that container. That's all I have to provide. Every other setting has good defaults. That's what we say by a simple developer experience. The only thing I need to provide, in addition to the image, is to say if I want to expose that service to the internet publicly. Like we want that to be a conscious choice. So in that case, I'm going to say, yes, I want to allow unauthenticated invocations. That basically means I'm going to be making a public website. I can go over the other settings later, but let's take a look. So right now, Cloudrun is importing my container image. It is starting one container instance to make sure that it starts successfully. Like before sending traffic to it, it starts one, make sure that it starts, and boom, like I haven't even finished talking, that it has given me already a stable and secure HTTPS endpoint for my service. So you see, in literally, less than 10 seconds, I deployed a container image, which, by the way, is quite big because it includes OpenOffice in the image. I'm going to go over that later.
So you mentioned the defaults are there, yes, but as you go through the configurations, you can set up CPU resource optimization, memory, etc. So, well, in what cases would you say like the defaults would be used versus actually going in and setting up the resource and performance optimization? That's going to, of course, differ based on the application stack.
Yeah. Let me show you those configurations, just so that I'm not lying. If I click that URL, instantly I have a container starting and serving this web page. And what does it do, by the way? It is transforming Microsoft Word documents. So right now it's uploading the document and it's transforming it to PDF. So like this is actually like quite relevant use case that is used by some of our customers. But it is not a trivial one. Like to do that Microsoft to PDF transformation, I do have to run OpenOffice in a container image. So to your point, yes, Cloudrun strives for good defaults, including secure by default, but I can go and customize a lot of things if I want to. So in that case, let's assume that we've noticed that our users are uploading Microsoft Word documents that are like way too big compared to the memory I've allocated to my container. So I can change that. You see, I could pick up to like 32 gigs of memory. Let's say I want 4 and maybe 2 CPUs because my Word to PDF conversion will be faster if I do so. I can customize.
Those are the defaults though on any Cloudrun instance. So if I go in and if I create a new Cloudrun service, those defaults are going to be the same across any application stack, which means, I mean, that's never going to work based on certain application stacks, right? So the whole idea of resource cost optimization, performance optimization, whatever you want to call it, is the ability to change that CPU and memory in gigs or megabytes or whatever. So with these defaults, those don't change based on the application that you're deploying, right? Like those defaults are just the defaults for any container.
It doesn't sound like it's an intelligent default. It doesn't
Right, like
analyze
no
what you're
forecast.
doing.
No, it is just not something you have to provide. And the default are, we look at the whole fleet, those defaults work for 99.99% of the deployed containers. However, some containers will need more RAM or more CPU. And in that case, if you have an out of memory error, Cloudrun will give you a very clear call to action. Hey, you'd better increase that memory limit. And in one click, you can redeploy. And all of those errors are automatically aggregated in cloud error reporting. So like in terms of settings, I obviously have environment variables. I can mount secrets both as an envar or as a volume. I can mount volumes like cloud storage volume in case I want to mount a cloud storage bucket as in my container file system. So there are a lot you can do. And on the security front, I can have, like, this is a very important setting, is do I want to run my container as a default identity, or do I want to give it a specific identity so that it can only do what it is supposed to do? And that's very a best practice to customize, and we are making recommendations for you to do that. And so let me.
All right, I got a question.
Does deploying that new? You see, I can even uncheck that I want to serve this revision immediately. Let's deploy and see what happens.
I got a question that's going to piggyback off what was just asked on this side, and it's probably going to be a similar ask to what they just said. So you provide T-shirt sizes in the kind of work, the templates, right? So you get a small, medium, large on how it's deployed. How do you roll that into automation?
To automate the setting, picking an exact memory amount?
Yeah, I know you can set up your own. I'm assuming you can set up your own configuration, right?
Yes, absolutely. So here, the UI dropdown indeed gives you a selection of popular memory limits, but this number is a continuum. You can actually pick like an exact memory amount that you want. And how would you determine that? By maybe looking at the built-in metrics that will tell you your memory utilization. And that memory utilization, like if you've picked 1 gig of RAM and you see that your memory utilization is actually 50%, then well, maybe your container would fit in a 512 megs of RAM, right? So where is it? Container memory utilization. You can see it's out of the box reported here, and we see like we went up to 30%, probably because to transform that word to PDF, we used I think 30% of the default memory.
So where I was going with the question was kind of off what was asked on that side is after you've run some predictive, can you right size the container to make it fit?
Yeah, and so let's take a look at how you would do that.
No, I think the question is, do you do it?
Yeah.
No.
Does Cloud Run do it? Like, does
Right.
Cloud Run say,
we-
hey, you might not be right-sized right now. Here's a
No,
recommendation.
we give you, yeah, no, so indeed, that recommendation is going to land, is going to be coming soon.
Okay.
But right now, we are offering you the memory utilization percentage. And based on that percentage, you can say, okay, well, I need to lower my memory if I'm using not enough, if I'm using just a bit, or if you get an out of memory error, you would clearly have a call to action to increase it.
So at this point where Cloud Run does not have a forecasted optimization capability that it'll automatically right size from a resource optimization perspective for you, you have to go in and manually do it.
Yes, and today Cloud Run proactively recommends you some cost optimization. For example, if you can switch between 2 CPU allocation mode, and if one would be cheaper for you, Cloud Run would tell you that. I mentioned some security recommendations where over time it will recommend you to adopt a more secure security settings, not on day 1, but on day 2. Like other recommendations include committed use discount. If Cloud Run sees that you have a baseline of usage, it will tell you, well, you probably should buy a committed use discount here because that will lower your cost on that usage. And now, indeed, it does not yet offer CPU and memory recommendations, but those ones are hopefully coming soon.
Can I ask you a little bit about, so many organizations already have a workflow that, they're working in Git repositories or whatever. How would you start this process? If, let's say I wanted to use the microservices template that's up on Git by you, and I want to hook it into some GitHub Actions to go flow that into my process versus manually doing it through a console. What does that take to set that?
Yeah, so I think you have 2 ways. Like if you go through Google Cloud's way, you would be connecting your GitHub repo, like with the flow I've shown, which is you basically have a GitHub authentication, and then you select your repo, you select your branch, and then it uses Cloud Build to trigger a build and deploy on every push. That is if you want to use Google Cloud's tooling. If you want to use GitHub Action, we offer official Google Cloud Run GitHub Actions to go from a repo. You configure the GitHub Action. You give your Google Cloud credentials, and it would deploy to Cloud Run. So it's really up to the customer. We have, as I said, full support for Terraform. In case you also want to store that configuration as code, like infrastructure as code, you would be able to use Terraform, or as you mentioned, even YAML. So let's take a look at this YAML. Indeed, it is a locked like a Kubernetes YAML on purpose. It's to enable portability, right? But as we shared, it is not running on Kubernetes. It is just using a compatible API that you could literally copy paste into a Kubernetes cluster to deploy it on Kubernetes.
Is this stateful? As in, let's say I make a change here, and then 3 weeks later I make a change in the console and I do a redeployment. Will whatever I change in YAML stay?
Yes, absolutely. If I can just zoom out, let me refresh. Yes. So the source of truth is the server. And when I open this YAML editor, I can edit, and it would edit the same source of truth as if I were to use the UI element or the command line. However, if you go the Terraform route and store the config in your Git repo, in that case, your Git repo should become the source of truth, and you should prevent your developers from touching the UI. You give them read-only access via IAM in that case. But yes, if I could, like, let's say I want to change the memory settings to 4 CPU and 8 gigs of RAM. I would do it literally by editing YAML if I want to. I would hit save. And again, I haven't talked about that, but a new revision would be created. So you see now we have 3 revisions, and I can, if I do want to do blue-green deployment, gradual rollouts, I can like gradually send traffic to my newly deployed revision. I can say I want to send maybe 10%. At Google, we always roll things out gradually. So when I do that, 10% of the traffic will start to go to my new version, my new revision. It's 10% of the traffic which actually hits that main endpoint. Like remember, I showed you this. So right now, 10% of the requests will go to the new revision, and 90% will go to the other one, and everything looks good. I can progressively roll things out.
So this is the blue-green strategy?
Right. Yes. And so I can even, if I want to, I can even assign a specific URL to a specific revision if that's the one I want to test explicitly. So I think one thing we haven't done is to send some load on that service, right? So I'm going to be using a small command line tool to send some load. I'm going to be sending like 1,000 requests in parallel, and maybe like 100,000 requests in total. So right now, when I do that, it's not only one container that will get started, but a lot. And so in just a few seconds, this whole traffic is going to be absorbed by my PDF conversion service. And we should get back a histogram of the latency, which I want to show you. So we see that like all of the 100,000 requests have returned 200 responses. And interestingly, most of them have been processed very fast, like less than 300 milliseconds, including the network latency, right? But some of them have taken more time, like some of them have taken 2 seconds to start. So why is that? It's because those have hit what we call a cold start. So those requests, Cloud Run, didn't have any available container for them, so it had to scale up a new one. And those requests had to wait for one container to be started. But as you see, when we talk about container startup on Cloud Run, we talk about 2 seconds. So 2 seconds to literally bring up a new instance, which is not a VM, it's an instance, and 2 seconds to start up the container itself and process the request, so which is still quite fast. So there's a lot to explore in Cloud Run, but I think now I want to head it off to Sridhar to tell you about what's new. But yeah, you see so many things, and Sridhar is going to be talking notably about networking and security settings that we've recently launched.
Sridhar, I'm an engineering manager at Cloud Run. I'm a bit of a believer when it comes to serverless. Back when I had my own startup, we used App Engine. This was way before Cloud Run even existed. So you'll see me be a bit excited, a little bit like a puppy. Just roll with it. So what am I going to talk about? Oh, let's skip forward. Okay. So we'll start off. I'll talk a bit about some of the new features that we have for Cloud Run. And after that, I'll talk about something that I work on a lot on a day-to-day basis, which is how Cloud Run works well for the enterprise. What we've seen here is where, Steren threw a container out there and it's scaled up automatically, super simple. You can throw something and make it available on the internet, very easy. When we take it to an enterprise context, all of you will know this, it's not as simple. There are more considerations. So we'll talk about that a little more. So first off, here are a few things that are new this year for Cloud Run. One of them is volume mounts. Steren talked about this. It makes it extremely easy to have some form of state in your container, especially if you've got large files. You just set up a mount point with GCF or with NFS, and Cloud Run automatically takes care of the whole mounting. It does this with a sidecar. It mounts it inside of that container, and it's extremely easy to access the same file or multiple files across all of your horizontally scaling containers. And it's also great for read-write use cases as long as you're not using something that requires concurrent writes to the same file.
So, quick question on that: with the volume mounts, what volume mount options or volume types are you supporting today? And are you looking to support other vendors' cloud volume mount options, like from NetApp or Dell or those? those
Good
folks?
question. Right now we support, well, it's not here on this slide, but we support in-memory volume mounts, just a regular in-memory system that you can use to share data between containers and sidecar systems. We support NFS, and we support cloud storage.
Okay.
In terms of future things, I don't have anything that we can talk about on the roadmap right now, but we are evaluating these continuously.
Ooh, I just want to confirm, read-write many does not exist currently. The reason why I ask is because, like, if I have 2 to 3 different containers that are writing to the same database, and I saw that there was a connection for a SQL when you're creating Cloud Run, so like you wouldn't be able to utilize this for like any type of stateful-based workloads from that perspective.
You can, as
Or
long as you're
persistent.
using, you can, as long as you're not using this specific feature. Like,
Okay,
what we recommend is that you use SQL, Cloud SQL, Firestore, all of those work.
got it.
So, and we'll talk about it a little later in this as well. A lot of our customers use it for stateful workloads where they have the state in a database or some other service maybe or something like that.
Not utilizing the volumes with Cloud Run.
Not utilizing.
Got it.
Cool. Okay. Now, this is something that we're actually very excited by. If you use Google-provided base images, what we now support is automatic security updates where what we're targeting is within 48 hours of a CVE, we will automatically patch your containers. We've been doing this for App Engine for years now. It's been more than a decade. And we've brought that technology to Cloud Run. And it's really great when you want that level of security where you can kind of say, hey, Google, you take care of the security for me. There are lots of issues that show up with, especially with the supply chain being what it is these days. We're using lots of open source products, and you bring them all in. You want a way to very quickly patch things when CVEs occur. And this is a feature that's now in private preview. I'd recommend all of you try it out. It's available for multiple languages, multiple runtimes. There's another feature that's recently launched in preview, which is, now if you saw Starin when he did the demo, what he did was deploy a Cloud Run service in a single region. Cloud Run is a regional service. It's deployed in a single region, but we've now brought a multi-region capability. And with the same command, you can deploy the same app in multiple regions. And if you provide a domain, we'll automatically set up a global endpoint for that domain so that when traffic gets to that global endpoint, it will get routed to the nearest Cloud Run region. And that provides you with a multi-region service with location-based routing with a single command. That's extremely powerful.
Are you providing like a visual architecture with heat map on like each of the regions? Like, all right, in San Francisco, you know, obviously we've like deployed 100 instances. In Paris, we've got 25, and Johannesburg, we've got 10. Like, we can see performance in each of those, because one of the things you highlight is how you're managing, right? But you're informing, right? And then working towards making recommendations on how to, you know, scale and grow that application. So
right now, we don't have a single screen where you can go and look at that kind of heat map.
Okay.
We are working with other parts of Google Cloud to provide that kind of capability where you have kind of a view across all of your regions, across all of your services, and you kind of see how traffic is across all of these.
So you probably have your list view that you showed at deploy. Is there filtering then to where you can look at each one of the regions?
Yeah.
Okay, so I don't have to sort by and then scroll.
No, like all of these are integrated with cloud monitoring, cloud logging, and so you have all of this visible, and you can build your own custom dashboards using those as well, so that you get the view that you really want to kind of look at.
Going back to your automatic updates, it said 0 downtime, 0 rebuild. How is that guaranteed for that? Is that a guarantee that you're saying there, or?
Yes, we are. So
How many nines?
All the nines. All the nines.
It's still in private preview. When we go to GA, we will give you the number of the SLO for this. Part of the reason we're able to make this work is because if you look at how Docker works and how all of these images work, they're layers. Right? And what we do is we swap out the layers underneath, And we do it in a way that we're able to validate that these runtimes are forward compatible and backward compatible.
It's like doing blue-green on your other application. They start rolling it out as they see it stable and works. Then they move all the workloads over to that new.
Okay.
And we've been doing this for App Engine forever.
Yeah.
So if you're on App Engine right now, you get this already, because with App Engine, you use the App Engine stack where you have the entire images which are already Google built. So we've just brought that capability now to Cloud Run.
So are you only doing the updates based on published CVEs or on also what Google knows and researches? Because the CVE publication right now has been very delayed. You know, they're months behind at this point.
I will have to get back to you on that.
Okay.
Yeah. I don't have that. Maybe Steren might have some context on that. The question is, are we doing this based on? Yeah.
It's mostly based on the language releases. So let's take an example. If you use Node.js, you have major, minor, and patch versions. And
I'm asking a slightly different question, which is not sort of how you do it, but when you decide to do it, are you doing it, the decision is only based on published CVEs in the CVE in the global CVE registry, or are you doing it based on Google research of known issues?
The reason why I'm bringing up language releases is that it all depends on when the language runtime will be patched itself.
Okay.
As soon as it is patched, it rolls out like within 48 hours to the whole Cloud Run fleet. But we are dependent on the language authors to issue a new release of that patched major version of the language.
So you monitor the release.
Yes.
Releases all the base
Across
images.
7 languages.
But it's possible you're also contributing to those patches as part of the open source efforts or initiative. It's not it's not your responsibility, but you may be a contributor.
Take Go as an example. Yeah. Obviously, Google is on top of this
a little bit,
directly a contributor. But some of the languages are more things we watch, and I think what we haven't said is that we never upgrade the major version. Like the Java major version is never going to be upgraded. So you still are in charge of going from Java 8 to Java 21 or whatever, right? So you should still think about upgrading your language runtimes, but the minor and patch versions are automatically updated for you as soon as possible.
Thank you, Star. Yes. So we talked about multi-region services, and now a lot of this is something that we spoke about at Cloud Next, and we're going to talk about this some more, and also have a bit of an interactive conversation about this. One thing that we've seen a lot of our customers start using Cloud Run for is in enterprise contexts. Now, these are going to be slightly different from your regular, you throw an app out there and make it available out onto the internet. What we've found is that there are usually a lot of different stakeholders here. It's going to be a security team who's worried about centralized security policy. It's going to be a network team, which is like, I will give you 5 IP addresses and that's all you get. And they set network policy. And you might have developers. And these developers want to move very fast, but also they want to move safely within the bounds that their organization has set. And where we found Cloud Run is really hitting a sweet spot is that because it's a managed service, because it allows a lot of policy to be set across organizations, these central teams can set policies, they can set things up, and then the developers can then move very fast within their product teams to go, oh, you know what? A lot of the infrastructure is just taken care of. And as Yunong said earlier, like Google is the platform team, right? And they don't need to worry about a lot of things when it comes to resource allocation, when it comes to lots of these small fine-grained decisions. They don't need to worry about it. The product teams can just move very fast. They build their containers because it's a container. That's a very simple interface. And then they can move extremely rapidly, and they can also work with scale. They can Cloud Run handles large scale. If you've got a CPU, a memory-hungry app, that works just fine. And whether it's one service, whether it's 100 services, 1,000 services, it scales really fast.
What's the cap for a container or CPU memory? So like, for example, in G-Key, if I'm remembering correctly, it's 110 pods per worker node. What's the cap for Cloud Run? As in how many containers, how much CPU I can use, how much memory I can use, because it's not infinite.
It's not infinite. The way it works is that we have quotas. And we don't really set a limitation based on pods per node or anything like that because we take care of it. As someone here asked about, I don't remember who it was, we run on Borg. And because of that, we have access to a very large amount of capacity and scale that we can scale to. We have certain default limits, but if you do need more, what we encourage you to do is just reach out to us, and then we can either procure more capacity if you don't have that amount of capacity in that region, or we'll tell you, hey, look, if you ask for 1 million, we won't be able to do it. But it's very much a conversation that we can have. So there are default limits, and I think it's about 10,000 instances by default. And beyond that, we have a lot of customers who do scale beyond that.
So there's a lot here. It's pretty broad. I would think immediately looking at this, okay, I have a big estate. I got lots of stuff going on in here. So can you help me understand, maybe not the proverbial low-lying fruit, but like what's the top or bottom half or whatever qualities of an enterprise workload that I would look to target for this? Because there are issues around control, integration especially, availability, that make me scared for a lot of run the business enterprise applications to even approach this. So can you
Definitely
elucidate that a little bit?
Yeah. Let's talk security. I'm going ahead because that was actually what I wanted to talk about.
I knew that.
Thank you. So one thing, and with enterprises, is they care about security, they care about compliance. And where Cloud Run fits really well into all of these is that it provides constructs that let security teams and compliance teams do kind of a horizontal vet of Cloud Run, shape their policies to kind of meet their enterprise needs across the board. And then once you've done that, every single individual team can just move very fast within those guardrails that they've set up.
So it was part of what you're saying is that for the operator or the application managers, they can create this, beneficial, beautiful environment that meets, let's say, class A or class C or whatever it is of their applications, and then present that back into the team and say, go for it. We've got guardrails for you.
Yeah.
And that makes that process simpler for the operator.
Yes.
Okay.
And it also provides a level of control that kind of hits a sweet spot. It might not give you as much control as GKE, for example, but it does provide all of the controls that you need to meet the security and compliance needs that, like, for example, we have very large banks using Cloud Run. And they went through all of these processes. And I can talk a bit about some of those. So a few things that come up is access control, for example. And Cloud Run has multiple layers of security here. You can set up IAM invoker-based checks so that all requests going into Cloud Run are authenticated and authorized. We integrate with VPC service controls, so you can set up VPC SC perimeters. And that is a way that we see a lot of large companies kind of establish controls on where data enters or exits some of these perimeters. If they want user logins, we integrate with identity-aware proxy. So you can put an SSO login or something like that in front of whatever the Cloud Run service is. And we've seen this used either for their own internal services where their employees are using it, or even for their customers where they integrate with their SSO systems and their customers can use it. And so this internal access control, there are a lot of options with Cloud Run.
So I could spend hours digging into all of this from the security side, but I think from the enterprise perspective, I think the biggest thing is how much of this is tied directly to Google's security tools, Google's IAM and VPC, and how much of it can the enterprise go to use their existing security stack?
That's a very good question. So what we try to do with Cloud Run is that we integrate with Google's tools in a way that we're not too opinionated. We just use a lot of what Google is using. So for example, we integrate with identity-aware proxy, right? Identity-aware proxy itself will allow you to use either Google or in some cases other identity providers and things like
Right.
that. So what we kind of do is almost say, hey, we will work really well with the Google tools, and they in turn allow you to federate in multiple different ways.
Okay, so there's at least one layer of interaction there, right?
There's
So for instance, you have, customer managed encryption key secrets manager integration. Is so that's going to Google Secrets Management, and then you have to go to the Google Secrets Management console to then integrate in your Enterprise Secrets Manager if you were using that instead.
Yes. Now, there are other options, which is we also provide very simple kind of integrations where we allow you to mount your own secrets, or we allow you to set your own environment variables. So there is a level of interaction where you can kind of punch through into the container itself if you don't want to use these integrations.
Right.
So another example is we have support for multiple containers. So if you want to use a sidecar model for your authorization or for network capabilities, you can do just that.
Right, and one of the things I saw early on with the other gentleman was that when you create a service, you automatically create a secure endpoint, right, for it. So how do you do certificate management for that?
Right. So what you can do over there is you can put it behind a load balancer. So then you can have your own custom certificates, whether it's an internal load balancer and you set up an internal domain, or if it's an external load balancer, you can set up your own certificate.
So I think part of what I'm seeing here, though, is sort of, and I think, Michael, you were talking about this earlier when you were digging into the default stuff is, and Paul mentioned this with the t-shirt sizing, right, is that as you enterprise and a lot of this becomes more and more customized and more integrated with an enterprise stack and the rest of what they're doing, how much do you have to punch out of Cloud Run to get what you need to do, and therefore you're maybe losing some of the value prop that Cloud Run is providing?
So, as always, there are trade-offs. Where I would say this works really well is that you'll have to make a few decisions to use standard GCP components. And Cloud Run works really well with them. But once you make those decisions and set up that central kind of policy framework, or maybe like you're not going to have each team do their own cert management, for example. You're going to have a central cert management system. And so once you have your internal load balancers set up and provisioned and working with that, then it's extremely simple to then just attach Cloud Run to it. And so you have your app teams have this nice little playground where they can move very fast, while the security and all of that is handled by the central teams.
Okay, so you just said a magic word there that was leading into my next question, right? When I think about enterprises who are investing a lot in caring about these things, they already have some maturity and understanding of how to use Kubernetes and containerization. Their teams already have platforms and services that they've been utilizing, right? So where then does Cloud Run really fit for an enterprise who already has some establishment? Now, the first thing I was thinking of is POC, right? Like this is our testing environment because nobody ever gets a proper testing environment. And then you could put specific guardrails, because the main value that I see here, and you touched on it at the very beginning, is that this is managed, right? You are the management provider for the platform. So how are you seeing enterprise customers gravitating towards Cloud Run? Or is it for the playground? Is it for the POC? Is it for the one business unit or the one feature group to be able to have something that they can run because they anticipate these challenges and these needs around scalability and whatnot? Or is it organizations who have never really gotten a good handle on using Kubernetes or GKE or whatever, and they're like, we really just want you to do more management on this?
Or the organizations that don't want to deal with Kubernetes anymore.
Exactly, yeah.
All of the above. So
Okay.
we have some large customers who are big Kubernetes shops who've decided that, hey, we don't want to deal with that for a lot of these, and they are starting to use Cloud Run in a bunch of places. We have large organizations who are essentially all in on Cloud Run and moving from on-premises workloads. So we've had some large banks who've seen literally a 90% cost savings from going from an on-premises system to Cloud Run. We have other companies, again, where they have their systems currently running in their on-premises clusters and all of that. They set up interconnect VPN, and then they start moving services onto Cloud Run, and they have this hybrid architecture where they're continually moving their workloads onto Cloud Run. So it's a mix of all of these. We see that customers are able to find value in Cloud Run across the board in a number of different scenarios. Okay, now I know that, Sterren has a bunch to talk about with LangChain and all of those. So I'll pause here. We're always happy to go into a lot more depth. We can set up more calls, conversations, whatever it is. Thank you.
Thanks. I'm going to keep going. One thing we really wanted to highlight regarding what's new is VPC connectivity. As Sridhar said, connecting Cloud Run to a VPC network is critical in the case of many real-life application setup, and that has become way better now with something that we call direct VPC. So simply your Cloud Run services are now on your VPC, which is very impactful for enterprise workloads, notably. So I'm going